This is section 2, some practice calculation problems. So the first question, an object undergoing uniform circular motion has constant uniform velocity. What's the answer? The answer is force. Now, why is it force? I need you to recall, let me divide my board into two. I need you to recall that, okay, velocity has two parts. Speed, okay, which is the magnitude, and then the direction. All right. Of course, we can define velocity as speed with direction. Now, if the speed is constant, now constant or uniform speed means that equal distances, okay, are covered in equal time interval. Let's say you have 2 meters, 4, 6, 8, like that. So equal distances in equal time intervals, no matter how small the time intervals may be. Okay, that's what? Uniform speed. But if the direction is the same, so if the speed is uniform and the direction is constant, then acceleration is equal to 0. Remember that if a body is either at rest or moving with uniform velocity, then A is equal to 0. Don't forget this. But the case of uniform circular motion is different. It's actually different because this body that is undergoing uniform circular motion has constant speed, v. All right, the speed is constant, but the direction is always changing. So at this point, the direction changes. At this point, the direction changes. Because the direction is always changing, even though the speed is constant, the velocity is what? Is variable. It's not uniform. Velocity is variable. Hence, the answer is false. All right, next slide. A body moving around a circular path of radius 6 cm made 200 revolutions in 1 minute. Its speed is equal to dash. Okay, now remember the popular formula equation. We have V. Again, let me divide my board. V is equal to omega R. Okay, let me see if you'll be confused. What if I write this way? V is equal to 2 pi f r. Will you be confused? Please don't, because omega is equal to 2 pi f. Is that okay? Now, what if I go ahead and rewrite it as V is equal to 2 pi nr all over t? Will you be confused? Okay, please don't be confused, because f, you remember, frequency is equal to what? The number of complete oscillations made. How? Okay, the time taken to make, sorry, the number of complete oscillations made in 1 second. That's frequency. All right, so we can as well replace it here, and then we get this. So having got V is equal to 2 pi nr all over t, plug in the values. It will give us what? 2 times 3.142 times n is the number of oscillations. In this case, we have what? We have 200 times r. R is 6 centimeters. Remember, that will be 0.06 meters. The base unit is meters, not cm. So you have to convert. All over time is 1 minute. And I hope you're not going to plug in that 1 minute. 1 minute is equal to 60 seconds, because the fundamental unit or the SI unit of time is seconds. Now, if you punch this out, you are going to get the answer to be 1.25. 1.25 meters per second. So option B is the answer. Next slide. A force F is required to keep a 5 kg mass moving around a circle of radius 3.5 kilometers at a speed of 7 meters per second. Full stop. What is the speed if the force is tripled? Okay, again, let me divide my board like this. Solution. What are the parameters we have? We have that mass is equal to 5 kg. All right, we have that the radius is given as 3.5 kilometers. But this is not the base unit, this is not the SI unit. So in meters, it will be 3.5 times 10 raised to power 3 in meters. What else do we know? We know that the speed V is 7 meters per second. All right. So the formula for centripetal force is equal to mass times speed squared or velocity squared all over r. I hope you've not forgotten. Okay, so if we plug in the values, we are going to get 5 times 7 squared all over 3500. Punch this, you will get F to be FC will give us 0.07 Newton. Okay, but this is not the answer to the question. The question now says, what is the speed if the force is tripled? So we can say F1 is equal to F. Now if F2 is now 3 times F1, all right, what will the V be? Now, I've always said that questions like this are relationship problems. That means in the formula, you have to concern yourself with just the quantities that are captured in the question. So in this case, we are going to just say F is proportional to what? To V squared. Every other parameter should be rendered 1. All right, that's constant. Okay, now if we establish the constant here, we'll have F is equal to K V squared. That means that F over V squared is a constant. So I can establish more. F over V squared. This one becomes 1, while this one becomes 2, right? So here, I now have F all over 7 squared is equal to what? I have 3F. If you like, you can plug in the real values, which the real value of F, which is 0.07. You can plug it in if you like, but I think it's much easier to just use F all over V squared, V2 squared. That's what we are looking for. Okay, let me make space here. So we finish it up. Okay. Pick my biro again. Now from here, let me the line here. So here, the F's will cancel. This F takes care of this F, and then we are left with 1 all over 49 is equal to 3 over V squared, of course V2 squared. All right. If you work this out, you will get that V2 is equal to the square root of 49 times 3. Okay, work that out and let's see. The answer V2, which is what we are looking for, should be 12.1. That's be 12.1 meters per second. So this option is the correct option. Next, the speed of an object in circular motion does not change because the work done by the centripetal force is zero. True or false? The answer is true. Now remember that, again, let me divide my board. Remember that work done is equal to force times distance. But of course, let me use times x. Alright? Let me use x as my distance. But this is not all. We don't normally put this cos theta. Actually, there should be cos theta. Alright? But because theta is always zero anytime a force acts on an object and causes that object to move a distance in the direction of the force, that means the angle is zero, and cos 0 is equal to 1. So that's why we've often written work done as force times distance, just like that. But in the case of a circular motion, this is a body undergoing circular motion. The speed or the velocity is at right angles to the centripetal force or the centripetal acceleration. All right, and remember that speed and displacement or the distance are parallel. So that means that FC is perpendicular to the distance. So you have angle 90 degrees here. So work done is equal to force times this guy, distance, times cos 90 degrees, and cos 90 is 0. Therefore, work done is equal to 0. So it's true. The last question. The gradient / slope of the linear graph of f against v squared for a body in circular motion is given by this. True or false? The answer is true. Now, why is it true? The formula for centripetal force is equal to mv squared all over r. Now, this can be written as Fc is equal to m over r v squared. If I like, I can put my intercept so that this will resemble the general equation for straight line. You remember y is equal to mx plus c. Can you see a kind of resemblance between this and this? Can you see that? That means this is the gradient or the slope.